the Y bar is equal to 8.154 millimeters, okay, from the top. Okay, and then the IZZ is equal to 3.8802 times 10 to the power minus 9 meter to the power 4. Okay, and the area is equal to 104 times 10 to the power minus 6 meter squared. Okay, so we have found our centroid. Okay, we have found our centroid to be over here. Right. So this distance from the top is 8.154 millimeters. Okay, so this is our centroid. Right, and then we already know that at the top of the centroid, this will be tensile, and at the bottom, this will be at what? Compression. So from here, what we're going to do now, okay, we're going to find the stress X at point A. Okay, or we're going to find stress X is equal to Px over A plus by Mz over Izz multiplied by Y. Okay, so now we're going to calculate Mz first. Okay, we know Px is equal to 400. We want to calculate Mz. So Mz, or we can do Px over A first. So Px over A is equal to 400 divided by the area, which is 104 times 10 to the power minus 6. So regardless whether point A, point B, or point D, the axial loading will always be the same. Okay, the axial loading will never change. 400 divided by 400 divided by 104 power minus 6. So this is equal to 3.846. Okay, 3.846 times 10 to the power 6 Pascal. Okay, this will not change at all. Okay. Now, moment about Z is equal to P multiplied by D plus by E. Okay. So P, we know is 400. D, right? D for this case is 50 millimeters is the D. So this is equal to 0.05. Plus by E, because we take the data from the top, is 8.154. Okay, so 8.154 times 10 to the power minus 3. Okay, so 8.154 power minus 3 plus 0.05. Okay, wait. 0.05 plus 8.154 power minus 3 times by 400. So it's equal to 23.262 16 Newton meter. Let me do it again. So 20 0.05 plus 8.154 power minus 3 times by 400. It's going to 3.261. So the moment. Now, this is with the data from the top, yeah? I want to show you, if you take the data from the bottom, is equal to 400 plus by 0.0, multiply by 0.05. You have to plus by what? Plus by 0.020, right? That's the entire length. And because you take it from the bottom, right? So you have to minus by, if you take it from the bottom, this will be equal to, if you take it from bottom, it's 11.846 millimeters from the bottom. Right? So the centroid from the bottom is equal to, so minus 11.846 times 10 to the power minus 3. So you have to extra term to consider, 0.05 plus by 0.02 minus 11.846 power minus 3, then times by 400 again. So it's all the same. Okay, so 23.2616. Right? So this is datum from the bottom. Okay, so you can see from yourself. Down here, I just plug one number. Down here, you have to add and take away again. Okay, you have to compensate. Right. So from here, I'm going to copy this whole thing. This is our analysis. Right. So from our analysis, right, from here, we can, now we have those numbers. Is really straight. So we're going to calculate stress X at point A. Right. So this is equal to positive, because the axial load is having tensile. So 3.846 times 10 to the power 6 plus Y plus, because the moment is going to induce a tensile load. Okay, tensile. So M, the moment is 23.2616. The Y is 8.154 times 10 to the power minus 3, right? Because this is the centroid, and at point A is 8.154 divided by I. So I mentioned that is equal to 3.8802 times 10 to the power minus 9. So this will be equal to, so 23.2616 times by 8.154 power minus 3 equal to, divide by 3.8802 power minus 9 plus by 3.846 power 6. So it's equal to 52.729. Okay, 52.729 times 10 to the power 6 Pascal. Okay, and then stress X. From the question, we want to calculate stress X at point D. So this is equal to 3.846 times 10 to the power 6. Okay, and then because it is under the bending, will induce a compression. So minus 23.2616 multiplied by 20 times 10 to the power minus 3 minus by 8.154 times 10 to the power minus 3. Okay, then we divide by 3.8802 times 10 to the power minus 9. So the Y is different. So what is this? So this over here, right? This distance over here is 20 minus by 8.154. So that's what is going on. Okay, so the outcome from this is equal to 20 plus minus 3 minus by 8.154 power minus 3 times by 23.2616 divided by 3.8802 power minus 9. So minus the moment plus by the axial load is 3. So it's equal to minus 67. Okay, minus 67.17 times 10 to the power 6 Pascal. Okay, and what you see over here always, so we know that for this equation over here, these two terms over here is because of axial loading. And then these terms over here, right, these are due to your bending moment, right? And then you get your final answer. Can someone tell me what can you observe from the final answer and the axial loading? Can someone make a comment? Okay, what can you see? if the material is going to fail, is it going to fail on axial loading or is it going to fail on bending moment?
Bending.
Absolutely right. Okay, so what you can see is that stresses induced by, absolutely right. So if you want to break something, you pull, it will not break. What will you do? You will bend and bend and bend, then you will break, right? So the stresses induced. So from here, what we can conclude is this: the stresses. Okay, what we can conclude is the stresses induced by bending moment, right, is higher than axial loading. Always the case, right? We do that unconsciously. We want to break something, you pull down, break, then we start to what? We start to bend. Okay. So now, part C. Okay, part C. Okay, we want to find the position of the neutral axis. So i.e. stress X is equal to 0. Okay, so if we look at this, all right, the axis, right? So we always look at this, right? So this is Y, and this is Z, and this is our rotation about X. Okay. So we want to find the position of the neutral axis when stress X. So if you look at if you look in the textbook, the formula is this: stress X is equal to Px over A, right? This is based on the formula, right? And minus mz over izz multiplied by y. So this is based on formula. Now, an easy thing to remember, why mz over izz is minus, because the z-axis is pointing towards the where? Left-hand side. When it's pointing towards the left-hand side, that's why it's equal to what? Minus, okay? Why this is minus, again? Because the z-axis is pointing towards the what? Left-hand side, okay? So that's why this is just memorizing based on the formula. Okay, if you cannot remember, then like, oh, okay. So let's derive this out first. Okay, so we know that stress X is equal to 0. Don't worry, I'll show you using high school math, we can find the neutral axis. You don't need to remember, but I want to show you this first. Okay, so this is 0 is equal to Px over A minus by mz over izz multiplied by y. So this is the condition at the neutral axis. Okay. Then you will have an expression where you have Px over A is equal to mz over izz multiplied by y. Okay. So for this case, you have Px over A. So Px over A is equal to 3 point, we know this, 3.846 times 10 to the power 6. So this is equal to mz. So this is moment, is the moment that we found on the previous one, is the moment is equal to what? The moment is equal to 33.2616. 33 divided by izz. So izz we know is equal to 3.8802 power minus 9, right? And then you multiply a y down here. Okay, so y, okay, so y is equal to 3.846 power 6 multiply 3.8802 power minus 9 divide by 23.2616. So this is equal to 0.6415